Okie dokie. So I just figured out how to do this problem. It's giving me some trouble. Let's talk through it. They say assume you know that the values in the table grow exponentially or decay exponentially, and they ask which of the following is the best match for the percent rate of change per year. Now, we'd easily be able to find this if these years went up like 1, 2, 3, 4, 5, and so like just went up 1, then 2, but they're going 1, then 3, then 5, and so on. So it's a little bit harder. So let's talk about it. We want to use this sort of exponential function. So what this kind of describes is there's some initial value, I guess, and then this 1 plus r is kind of the key. So we need to solve for r in this, hypothetical equation something. So we're going to pick just two ordered pairs to run with. We're going to use 779 as the y value corresponding to a t value of 3, 30.8 as a y value corresponding to a t value of 1. We're going to set up those two equations. 7.79 equals a times 1 plus r to the t, which is 3. And we're going to divide that by the second equation with 30.8 equals a times 1 plus r to the 1. So our goal here, again, is to solve for r. We are going to divide the left sides by each other and the right sides by each other. So let's go ahead and calculate 7.79 divided by 30.8. 7.79 divided by 30.8. We get about 0.2529. 22. All right. So then on the right side, the a's will cancel. And this is kind of weird, but we're left with 1 plus r cubed over 1 plus r. We have 3 1 plus r's on top and just 1 on the bottom. We can eliminate one of them on the bottom and one of them on the top, leaving us with 1 plus r squared. Again, we're solving for r, so the thing we do next is take the square root of both sides to eliminate that square right there. So we're going to take the square root of this value here. So try to just put a square root around all this. I don't think that's going to work. Let's try this. 0.252922. We get about 0.5029. Equals 1 plus r. And to get r by itself, we just subtract by 1. So this minus 1 gives us negative 0.497. That is our r value. So that is our percent rate of change per year. So the r value describes the rate of change of those values per year. So once we find that, we are done. I'm going to go ahead and do 2 more examples, and I'll kind of show you how to do this same thing. I'll just describe it in kind of a shortcut-y sort of way, so we don't have to write out all this stuff every time. So to kind of apply the shortcut to this one, all you have to do is take this number, divide it by this number, and then however far apart these two numbers are, 1 and 3, will tell us what sort of root we have to take. I hope that makes sense. So like 1 and 3 are 2 apart. So that tells us we have to take a square root. If they were 3 apart, we'd have to take a cube root, and so on. So once we take that square root, that would get us the 0.5029, and then once we do that root, we subtract by 1, and that gives us the answer. So let me try that shortcut with this, and hopefully it'll make a little bit more sense. So for this one, taking these first two values, I'm just going to divide these two. So I'm going to do 0.821 divided by 1.03. Then, however far apart these are, I'm going to take that root of this result here. So I'm going to take the first root, but that's really just, raising it to a power of 1 over 1, which doesn't change it. So pretty bad first example to do with the shortcut, I'm sorry. But so we really don't have to change this result. Once we do whatever root we have to do, we subtract by 1. So let's demonstrate this in Desmos, or calculate this in Desmos. 0.821 over 1.03, and then we subtract by 1. We get about 0.20. So about 0.20, which is close to a couple of the answers, but it's closest to C. Sorry, this should be a negative. And then if we ever wanted to make extra sure, again, we could use any of the other values. So let's try these two. We're going to do 0.527 divided by 0.658. We're going to take the first root because 6 and 7 are just one apart, so we don't have to change it really. The first root just keeps it the same. Then we subtract by 1. 0.527 divided by 658, then minus 1. And we get just a slightly different answer, which helps us out by confirming that the answer is negative 0.199. And so that means C is definitely our answer. Let's do one more example, which hopefully will be a little bit stronger here. We take this divided by this, so 10.2 divided by 4.26. Here, 3 and 6 are 3 apart, which means we take the cube root. And then we're going to subtract by 1. So I'm just going to do this all in one fell swoop in decimals. We're going to take the cube root. Where is that function? Better have a cube root. We'll use that. We'll use a cube root of 10.2 divided by 4.26. And again, we subtract 1, so we get about 0.338. 0.338, which rounds to about 0.34, and we're done. So that's kind of the shortcutty way of doing the same thing we did with the long method at the very start. I hope this makes sense. If you have any questions, let me know.